Hey, hi. Shall we start our interview?
Yes, sure.
Yeah. Yeah. This interview is basically on Kubernetes.
Okay.
Pio, yeah. Can you please explain about your project how you used your Kubernetes in your project? So, brief, just can you please explain about the project?
Yeah, sure. So I've been involved in a couple of projects, like with Kubernetes. So wherein the first project was like the applications were deployed on bare metal. So it was kind of 16 to 20 services. So then we had to write uh, Kubernetes objects for that and then deploy it onto the Kubernetes cluster.
Mm-hmm.
And then, so for that, like we had used a lot of objects like deployment services, network policies, all these kind of objects. And then we have to deploy it to the Kubernetes cluster. And
Mm-hmm.
other project, it was in Spring Boot, wherein like, again, it was kind of a microservices architecture. So they had
Mm-hmm.
used a lot of like applications like Zool, API gateway, these kind of stuff. So we wanted to have a communication between each microservices to complete the project. Yeah, basically, if I want to say in a full way, like I was a developer, like a Kubernetes developer. So
Mm-hmm.
less into this administrative thing, but more into creating objects and converting application, migrating application. So these kind of stuff.
Okay,
And
that's good. Yeah.
so objects, coming to objects that I've worked on, a couple of objects like services, deployments, and then network policies, and I know like port security policies. So,
Yeah.
and also liveness readiness probe. So these kind of things I've worked on.
Okay, that's really good. Yeah, you told liveness probe, readiness probe, right?
Yeah.
There's one more health check startup probe. Are you aware of that?
Yes, actually, but I've forgotten. But I guess it is once the application even. So I'm not sure. No, I'm not sorry. I'm not
Yeah,
sure about that.
that's
But
true. That's correct what you're telling me. So for legacy applications, right?
Mhm.
So few application will take some time. So what you do is like you start up this using Startup Pro. So where you will so normally if the application is getting delayed while starting, so what kubectl will do is as it is not starting, it will start killing up the application
Yeah.
to
So
avoid
I've
so in order
heard
to
somewhere,
avoid that.
but I've read about
So,
that. But
yeah. So
but I've
it's
not used
basically
in
for
my project. So that's the reason.
yeah, so that is used for the application, because pure the application will take some time to start up.
Yeah. Correct.
So
Exactly.
we will mention in Startup Pro, we'll mention what is the time actually it is taking to start. So where we
Hmm.
mention there, and we'll let's say for example 10 seconds or 20 seconds. So meanwhile, kubectl will not kill the application. So while the Startup probe executed, right, this liveness and readiness probe will stop by the Startup probe. Okay,
Uh-huh. Okay.
therein
So until
Startup
startup
probe,
probe
yeah,
like
exactly.
it is successful, so liveness and readiness probe won't
So
work.
once it got successful, then we start with then it will start liveness probe and readiness probe will come into
Hmm.
picture. Yeah,
Yeah.
that's it. Yeah, that's good. Oh yeah. Sorry. Yeah. I just wanted to sort of ask you. You know about services in Kubernetes, right?
Yes. Yeah.
Yeah. Can you please explain about headless service in a brief? I don't want in detail. Just like headless service, where do you use that?
Headless service is basically, for example, let's say when you create a cluster IP, so it'll act as a load balancer between your pods. Let's say you have
Okay.
three replicas. So when you create a service, cluster IP or a node port, anything, so it'll act as a load balancer. So when you send the request, it can go to any pod. So in, for example, let's say I don't want that kind of behavior. I want to have a pod to pod communication, or if I send a request, it should go to a particular pod. In that case, so I'll go for headless. So if you want to say, take a simple example, let's say I have a MySQL DB. So
Mm-hmm.
when you have three replicas of MySQL DB, and when you create a cluster IP, so what happens? I mean, the write request and read request, if it goes to different replicas, there is no data consistency will be there. So in
Okay.
that case, you need to keep one um, pod as like your master and others as slave. By using headless service, that is what we will be able to. By using for every pod, you'll have single service, like in a layman terms, if you want to say.
Yeah. That's good. I'm good with that. Yeah. So with that, we'll move to the question. Uh, yeah. You want to maintain your application is highly available, right?
Mm-hmm.
So what will you do from your point of view? Like, what are the concepts which you will adopt, or what are the practices, best practices, which will make your application highly available?
Yeah, so in this case, we can use a lot of concepts. The first one is if you want to make your application, assume like you are getting too much traffic. So the first thing is that what you will do is like you will maintain number of replicas, more number of replicas. Okay.
Yeah.
And also like with this, we can create a HPA or VPA, horizontal pod autoscalers and virtual pod autoscalers. So
Okay.
depending on it, like you can't create both the things on the single deployment, but depending
Okay.
on your situation, which one you want HPA, you can create it, or VPA if you want, you can create it. So these
Okay.
are these things with this like liveness probe, readiness probe. So those things will maintain. So if your container stuck in between, once the application started, it worked for 2 minutes and it is stuck somewhere. So by
Okay.
using liveness probe, you can restart your container. So that you can
Okay.
do. And readiness probe, wherein once the application container is ready to accept the request. So by using that, wherein you can make sure until that like the service, the pod won't get any requests. You can make sure that as well. And also
Okay.
with that, we can also use network policies. So for example, let's say you have any database pod, so in for that particular pod, you shouldn't have communication between any other pod. Like for example, let's say I work in some kind of finance department. Okay,
Okay.
so when I have a finance department pod, so which has a data related to financial things, right? So
Okay.
none of the other teams should be able to access that particular database. So in that
Okay.
case, when you create a cluster IP, even though if you create a cluster IP, what happens? Like you can create one more pod in the cluster and you can access it.
That's
But if
correct.
you want to avoid that, you can use network policies and you can restrict from which pod you'll be able to receive and you'll be able to send. So
Okay.
those kind of things and headless, I mean, like that is not as a part of high availability, but individual services. That's it.
Yeah, that's true.
So
So yeah.
these are the
That's
things,
good.
and also I'll make sure whatever the application container I'll run, right?
Hmm.
So the image and the process inside that it will be minimal. If anything, like the big files which as a part of application downloads, so then I'll keep it in init container, and then by using a volumes concept, like wherein I can keep my files, I can mount it those volumes onto my application container, and also if anything extra thing which is required, so I'll keep helper containers, and by using that I can achieve that as well.
That's
So and
good.
also like if it is stateful, I'll go with the volumes. I'll make sure I won't lose any data.
Good.
So these things.
Yeah. Just with curiosity, so which one you've been used? Is it HPA and VPA both, or only HPA used currently?
I mean, for POC purpose, I've did on VPA, but HPA, I know HPA, original pod autoscaler.
That's good. Okay. Okay. Good with that. So, shall we move to another question? Yeah. Yeah. You know about the namespaces, right?
Yes, yeah.
So, let's say you created a Kubernetes,
Hmm.
setup. So, what will the default namespaces, which were created as part of Kubernetes?
Yeah,
I mean, like while you set up the initial, yeah.
yeah, so it depends on the like which installation methodology you will take. So basically three namespaces which will be default namespace and also kube system and kube public. But in some of the installation methods you'll also get kube node lease. So these four namespaces it will be created by default.
Okay. So, normally you know about the resource quota, right?
Yeah.
So why we attach this resource quota to the namespaces?
Yeah, I mean, it is basically, I mean, this object is related to admin. For example, let's say he has limited clusters, limited nodes, and
Hmm.
it has been given to multiple teams. Assume like there is a cluster with one master and four nodes, and it has been assigned with two teams. So to make
Okay.
sure they won't overuse it, like, I mean, many pods, many deployments. So wherein you can create a resource quota on each namespace,
Okay.
wherein you can specify how many pods you can create, how many replicas you can create, and what is the requested memory you can mention. So by this,
Okay.
like, we can restrict kind of like resources can be used for the particular namespace. So obviously the namespace will be assigned to a particular different teams, right? So
Okay.
that's where, like, to limit exactly the what resources they want to create. So you can
Okay.
mention it in resource quota, attach it to
That's good.
namespace.
Yeah, that's good. Okay. So, what are the volume types that are available in Kubernetes, or uh, I mean, like in your project, which one you've been used? Which type of what type of volume you are being used,
So we
or any
had
persistent volume? Like any persistent volume has been used in your project.
yes, yes. I mean, there are a couple of volume types we have used.
Mhm.
So empty directory, and we had used a host path, and
Okay.
also, like, we had used the NFS server mounting. So as a persistent data, so wherein, like, we had a couple of applications, so wherein we wanted to store the data in NFS, and, like, even if that restarts, so we wanted that data. So yes, I have worked on persistent as well as, like, empty directory if you want to share the, like, any data between init containers and application container. So that time I've
Okay.
created a empty directory volume and then use it as a mount path in both the
Okay.
containers.
Okay. That's good. So yeah, have you ever used adapter containers? Like
uh,
which situation, if so, if you
I have
use it?
not used it, but I know what the container patterns are like. In my case, I've used a sidecar container because in one of the situation, I wanted to send the logs from my container onto Splunk server. So I'd used a Splunk forwarder container as a sidecar. But yeah, I know adapter container is basically whenever, for example, let's say you have some application which is generating logs in XML format. Okay, so but assume, like, your monitoring solution is Prometheus, wherein, like, you don't have, like, Prometheus can't understand XML. So there should be some data exchanger, kind of like, you should change the data, like XML, you should take XML and you need to convert the data which will be understood by Prometheus. So if that kind of a container, if we have, so that is what we will call it as adapter containers.
Okay, that's good. Yeah. So you know about config map, right?
Yes, yeah, yes, correct.
So while working with did you face any issues like, for example, copying file to the folder uh, where you have already few files in there?
Yes, like config map, when we used, a lot of issues we had faced. So and also in our project, we are using Helm as well. So what happens when you have kind of like special characters? Let's say you have some special characters inside your config map. So that time we had faced issues like wherein Helm template is not able to, like, render it properly. So that
Okay.
time, what we did was, like, we encoded base64 encoded
Okay.
like one time, and when we had copied that files onto the container, in the startup command itself, we had given decode, like, decode that file and place it. Uh, we had copied it to the temporary folder and decode it and copy it to a proper folder. So that one, and one more thing was, for example, let's say you have some files which has to be copied onto the container which has
Okay.
already few files. For example,
Mhm.
let's say you have some file, so which
Okay.
has to be copied under root slash var lib or somewhere. Okay, so
Mhm.
obviously var lib will have definitely files, right? So
Yeah.
if it has any files, so in that case, if you try to copy file from config map onto that particular folder, so if you
Okay.
don't use subpath, so it'll delete the old files. It'll only keep the new file.
Okay.
So to if you want to copy the files to the folder which has already some files, so then you need to use subpath. So then it'll solve your problem.
Okay. Yeah. That's good. Yeah, with that we can move to the another question. Yeah, for example, let's say I have a database container. Okay,
Hmm.
we should accept requests only from particular IP
Yeah.
or from specific pod. So this is my requirement. How would you configure it?
Yeah, this I've already mentioned, right? Like I mean, high availability, wherein like, for example, if you have a database container, wherein if you want to take any request, basically, if you want to accept only requests from particular container, so then you
Okay.
need to use a network policy. Under that, we have couple of selectors, pod selector, namespace selector. So these
Okay.
kind of IP block. So we can use any one of it. But as your case, I mean, in your case, it should accept from some particular connector, sorry, container. So in that case, you can use a pod selector, and then you can mention the label of the pod where it should accept the request.
Okay. Okay. So what type of scaling methods you have used in your project?
HPA, I mean, like I know HPA, but VPA, I just know how it is. That's it. Like HPA was the one like I'd used in my project.
Okay. Yeah, you already explained about it. That's good. Yeah. So can you tell in us in which situation pod might go to, pending status? Like, for example, pod status is running,
Mm-hmm.
but in ready column, it is showing as something like zero out of one container. So what does that mean actually?
So in that case, maybe the container is still starting, so it is taking the time. Uh, Maybe like readiness probe is comes into picture in that case. So wherein like the content pod is started, but even the still the readiness probe is not checked properly. I mean, it is checking like if until unless the readiness probe is successful, it won't set one by one. It will be till then like until your readiness probe uh, successful, it will be 0 out of 1 only. I guess that is the reason wherein it will be still in 0 out of 1. So once the readiness probe successful, so it will be 1 out of 1.
Okay, that's good. Yeah. So let's say I have some elastic search pod. My requirement is this pod has a particular node,
Hmm.
and also that node should not accept any other pod.
So in that case, I didn't get your question. Could you
Yeah,
repeat
sorry.
it?
Say, for example, let's say I have elastic search pod. Okay.
Uh-huh.
So my requirement is like, okay, this particular pod has to
Hmm.
as particular node, and also that node should not accept any other pod.
Okay, so in this case, maybe I can use the combination of taint and toleration with the node affinity or node selector. First, in the node, we need to create a taint, wherein like you can create a taint, so which should accept only elastic pods. So, I mean, depending on your requirement, you can set as no scheduler. Some operations are there. So you can set
Okay.
it, you can, I mean, I'm telling about the overall concept. You can set a taint on your node, and when you deploy your pod, right? So you need to have two things. One is you need to have a toleration, and also with that you need to have a node affinity. So
Okay.
wherein like you'll specify the labels of this particular one. So if you want to tell, first you need to create a taint and also a label for a particular node where you want to deploy your Elasticsearch. And when it comes to pod, it should have a toleration and also it should have pod affinity or pod selector. So I'll go with pod affinity and we can deploy a particular pod on that specific node only. And
Okay.
that node won't be able to I mean, node will not be accepting other pods if no toleration is not there on that particular pod.
Okay. Yeah. Good. So, do you know about pod distribution budgets?
Yeah, pod disruption budget, right?
Oh, I'm really sorry. Yeah, that yeah, disruption budget.
Yeah, pod disruption budget. Yes, I know. So, I mean, I just know about it. As I said, like I'm completely into Kubernetes development. I mean, working on objects.
Okay.
Pod disruption budget. When you want to, for example, any voluntary disruptions happens, like if anyone like disconnecting the node from the cluster, or like something like for the upgrade or repair something, like if they're doing a drain of a node. So you want to make sure your application, for example, let's say there is some web page, it should be always up and running. Even though like if there is a maintenance, you need to stop. If the maintenance is going on, if that number of replicas of that particular application, at least one, it should be always running. So if any these kind of voluntary disruptions happens,
Okay.
so like it will be avoiding, like it will throw an error saying that no, there is a pod disruption which is assigned for this particular application. So make sure there is a one available node wherein I can deploy this particular pod there. So unless that, I won't be able to drain the node. This voluntary disruption is not possible.
Okay. Yeah. Okay. Fine. So you are aware of operators in Kubernetes?
Yeah, a bit, that's it. But I mean, I know that's it.
Okay. So you're okay. Then fine. Okay.
Yeah, in
So
one of the case when in like backup, and when you especially go for databases, wherein
okay.
like the backup and making replicas and maintaining those things and all, it will be very difficult. So wherein in that case you can make use of operators, and then you can do those activities very easily. So
Okay.
that, I mean, that part I know. That's
Yeah. So basically, that will be used for deploying a stateful application. So yeah,
yeah, yeah,
that's the
right,
major reason.
right. Yeah.
And are you aware of this control loop mechanism in Kubernetes?
No, sorry,
Yeah.
I'm not aware of that.
Okay, no problem. Yeah. Basically, there's a default um, mechanism which Kubernetes has actually. So
Okay.
it had three parts where it will observe the change, observe for any change. For example, if the user runs any command, right? So it's a
Hmm.
desired state. So then it will observe, and then it will take action accordingly. So
Okay.
that's about control. I mean, control plane actions. Actually, yeah,
Hmm.
that's fine. So, what about this CRDs? Any idea about that?
Custom resource definitions.
That's true. Yeah.
So, I mean, which is related to operators itself, wherein
Yeah.
like
Okay.
if you want to create any extension by using your already existed objects,
Okay.
so then you'll go and you'll write custom resource definitions.
Okay.
Um, I mean, like that is what I know. But basically, this is written on some languages, and I guess it can be written by using Golang as well.
Okay.
So
That's good.
that is about it. I mean, that much I know. But
Yeah,
yeah.
that's good. So, with this, I'm done with. So, have you aware of this? Have you worked on Helm?
Yes, I worked on Helm. Yes.
Okay. So, basically, um, why it is used for any idea? I mean, like,
Yeah, it is a, I mean, package manager wherein in Kubernetes, like for example, let's say if you want to deploy application, you need to use a lot of objects. So if you want to deploy a simple application, so for example, database application, your application has database and a front end or a API. So it is very difficult to manage all the object files, right? Service, deployment, network policies.
that's
So there
true.
will be a lot of objects. So by using these Helm, wherein you can, with a single go, you can create all the objects and maintaining the YML format. And if any values are changing continuously, so
Okay.
in that case, Helm plays a very important role. For example, let's say the whatever the tag, if I want to say like the metadata tag will be there, right? Under that, the annotations, labels, it is continuously changing. Okay, so
Okay.
in that case, you need to completely rewrite, not completely rewrite. You need to change in all the object files, right? So rather than that, like use a Helm, whatever the value that is changing regularly, you can just send it from put it in values.yml, and by using which, like if you change in one place, it will be affected in a couple of objects. So that is one thing. And yeah, with a single go, you can create all the object. That is
Okay.
also a very important thing. So yeah, this is about, and the ports, especially ports, if your application ports are changing from one port to other ports, so rather than like changing it in service YML, you can change it in values.yml. It will be taken into account there, like when it renders it.
Okay. So, I mean, which version you use, Helm 2 or
Helm
Helm 3 in
3,
your project?
Helm
Helm
3
3.
I've used.
So, what is the difference between Helm 2 and Helm 3? Any idea?
Yeah, Helm 2, it has three levels of architecture. I can say it has a Helm client and it has a tiller server, and
Okay.
also kube API server, Kubernetes cluster. So everything has to go via tiller only. So because in previous versions of Kubernetes, so when the Helm 2 came into picture, then RBAC rules were not there. Role-based access control. This was not there. So that's why they had to maintain all the renderation, and talking to Kubernetes cluster should be handled by Helm itself. So that's why they had a tiller component. But when it comes to Helm 3, so it can be used only with the latest versions. Means like I guess like from 1.16 from onwards you can use the Helm 3. Wherein after Kubernetes 1.16 they have introduced all this role-based access controls, right? So with that,
Okay.
like they had removed the tiller component. So and it they make sure that like the now architecture is very simple. They had only Helm client. So Helm client will be sending a commands, and wherein it will gonna uh, uh, interacts with Kube API server, and like it will gonna execute everything. So now tiller component is not there. So this is a major difference, but there are a
Okay.
couple of other differences as well. Two-way merge patch and three-way merge patch.
Okay.
So for example, if you change anything manually in Helm 2, for example, you have created a deployment and somebody manually went to a Kubernetes cluster, they updated a deployment file with some other configurations. So when you do again a Helm upgrade, so those manual changes will be ignored. It doesn't count actually. It will just if no changes there in the chart, it will just ignore it. It doesn't take the changes that you made manually to the Kubernetes objects. But in
Okay.
Helm 3 it's a three-way merge strategy, wherein like it will consider, so it will check is there any change in the chart, or is there any change in the local objects that in the objects that you have created in Kubernetes cluster. So it will check, verify both the things. If any change is there, it will gonna consider that as well. These things, and schema verifications are there, and many comments has been changed. And like the release names are specific to namespaces in Helm 3, but when it comes to Helm 2, it is global. It's not specific to namespace. And automatically in Helm 2, it used to create namespaces, I guess. In Helm 3, it is not there. So
Okay.
these kind of things.
That's good. So, yeah, how many clusters do you support in your
So
project,
we
and
we
how
had
yeah.
three clusters. I mean, it was just 16 projects wherein like services I said, right? So
Okay.
wherein like per environment they were maintaining it.
Okay.
We had just like want to run some pipeline to deploy it onto the different clusters depending on the environment variable that we will gonna supply to
Okay.
Ansible playbook to while running it.
Good. Good. Okay. That's good. With that, I'm done with my interview.
Yeah,
Yeah, that's a great session. Yeah.
yeah.
Thank
Thank
you.
you. Yeah. Bye. Thank you.